Welcome back, everyone. I'll give a little bit of an introduction about our second session and give some people time to filter back in and get back in from a walk or a cup of coffee. We're going to start session 2 now of the symposium entitled Bioextraction in Context. This session will include connections to the ideas surrounding regenerative ocean farming, the uses of bioextracted materials, and how people are thinking about and using bioextraction as a learning concept. Our first speaker is Samantha Garwin from Greenwave. She leads Greenwave's market innovation program, which works to identify and overcome market barriers and open new sales channels for farmers across the US. And she'll be speaking about how her organization thinks about seaweed in a regenerative ocean farming context. And thoughts around uses of harvested seaweed beyond food that could have implications for bioextraction. Just as a reminder, please put your questions for Sam in the chat. And also if you're not speaking, please turn off your microphones and your cameras as well. Thank you. Sam, the floor is yours when you wish.
All right. Thank you, Jordan. Okay, here we go. Hi, everyone. As Jordan said, I am Sam Garwin. I work with Greenwave, leading strategy for the Market Innovation Program. And many of you know who or what Greenwave does as an organization, but for those of you who don't, Greenwave is a New Haven, Connecticut-based organization that is focused on training and supporting regenerative ocean farmers in an era of climate change. And as we've heard today, there are lots of benefits of farming kelp, but it's a brand new industry and not necessarily an easy or intuitive one to get into. So our two main areas that we focus on are training and support. And that's both getting farmers into the water and then supporting them as they scale. And then also innovation to really remove those barriers that might prevent people from either getting into the market to begin with or staying there. And a lot of that has to do with market uses for their kelp, because after all, most people who are doing this, unless it's philanthropically funded, these are going to be for-profit businesses and people need to make a living so they can keep doing this work in the long term. So our training kind of comes in two forms. One is intensive farmer training, which is very hands-on, help with site selection, farm planning, permitting, farm installation, hatchery design and setup, and sales and marketing support. And then we also have this Ocean Farming Hub, which I kind of plugged for one of the questions that just came up recently. So look in the chat for a link to that. But this is a resource that has all of our written materials, videos, and a community forum where people can learn about ocean farming and kind of get started without having to wait for Greenwave to necessarily come and do that high touch training in their communities. So to get back to this kind of high level concept of regenerative, what makes an ocean farm regenerative? There's of course these environmental benefits, but there's a lot more to it as well. When Greenwave talks about regenerative ocean farming, what we are really referring to, the model that we promote is IMTA, so integrated multi-trophic aquaculture, which just means we have multiple species in this one pretty small footprint. And as we've heard, having seaweed and shellfish in an area together has a lot of benefits, from removing excess nutrients, which is what this entire event is about, to creating habitat structure where other species that exist in the marine environment can have a place to live, to feed, to reproduce, to hide from predators. And there are some studies that have shown that the biodiversity in a given area can actually increase up to 25% just from having this kelp farm in the water. So when we talk about regeneration, we're talking about both removing some of the excess of nutrients that we have applied using perhaps industrial methods on land. So actively fixing the environment that we have perhaps degraded over the last 50 to 100 years. But we're also creating active good in addition to fixing some of the negative things that we've been talking about for the past hour or two. But it's not just environmental. So there are social implications, there are economic implications. And one of the things that we really like about ocean farming and kelp is that it's a winter crop. So, we've been talking about in the last session how there are more nutrients in the water in the summer. However, as a winter crop, the way it currently is grown, it really complements existing fisheries and recreational activities, which is a boon to the working waterfront. It is a really important aspect in terms of smoothing out income streams for people who are doing those other activities at other times of years. Of course, it requires no feed, fertilizer, fresh water to grow. It's able to get all of its nutrients from the ocean. So we're not creating more stuff in order to do this other than putting the gear in the water. And the minimal aesthetic impact is also really important. When you think about a lot of farms on land, particularly in industrial settings, nobody wants to live near them. And so keeping these farms very minimal is really important to what a lot of folks in Maine and Alaska are referring to as social license. I'm sure it's an issue with some communities, and it will be an issue in Long Island as well, as more people want to put kelp farms in the water, but we need to have the folks who are on land supportive of that. And so, a kelp farm, being that it's just this, kind of picturesque grid of buoys is a real benefit there. So when we think about bioextraction in the context of markets, the Market Innovation Program really focuses on everything that happens to kelp after it comes out of the water. So who is it being sold to, in what format, for how much money, how's it getting there? We really like to think about a portfolio of uses for kelp. We're not targeting just one product. We need to have a variety of products that meet a variety of different grades, volumes, price points in order for scale to be effective and in order for farmers to make money. And so we really think of it in terms of, fresh food being the highest margin but lowest volume crop or product that you can get out of a given harvest. And then kind of going down from there, you're going to have higher volumes in general, but probably have lower margins. And so we are really interested in right now the food market. That's kind of the easiest to get into. And then with more processing, you can get into things like biomaterials. And of course, we're going to hear a lot more today about agriculture. And we touched on that in the last session, these ideas of biostimulants that are beneficial to plants and can help kind of close those nutrient loops and pull nutrients uphill, taking them out of the water and reapplying them. So the seaweed supply chain is one that is very nascent, still very much coming into being. But the most important thing to me that I think some people sometimes miss when they think about the supply chain is that there's actually two stages of processing. And the primary processing stage is the one that has to happen within hours or days of harvesting. And this really determines both the end product quality and shelf life. And it also even just determines like what your final products are. So what you do with it in that initial harvest is absolutely critical. And it's not till the secondary processing stage where you've got your stable kelp, whether that's frozen, dried, fermented, whatever it is, that you're turning it into a value-added product. And so the secondary processing companies are, that would be like Akua, a company that is buying a stabilized kelp product using specialized material, and they're not really going to be as tuned in to the harvest cycle because they don't care. They're buying stabilized kelp. So primary processing is a really, really important stage. And this is where, the first thing that we are expecting is going to happen as the industry gets bigger and there are more and more independent processors, is that there's going to be this cleaning and grading stage that determines whether the kelp that has come in the door is going to those food uses or whether it is going to go through a biorefining process to end up in biostimulants, materials, and extracts. And when we talk about biorefining, what we mean is taking this big old biomass, which perhaps is not food grade or not good for other uses, turning it into any number of materials and or energy. And so I'm not going to read off all of these items here, but the point is there are a lot of different things, and they are all contained in this one crop. And by utilizing different methods, whether it's microwaves or chemicals or fermentation, we can get access to these and through additional processing, refine them and then sell them. And this is a way that we are going to capture more value, essentially, from the kelp that's being harvested. One that several other people in this session are going to go into more that I just wanted to touch on is this idea of biostimulants. And Mike Dole, just as he mentioned, kelp is actually not that great from a NPK perspective. And so this word fertilizer kind of sets us up for a challenge in competing with something like cow manure, which is just full of nitrogen and is not really a suitable comparison for something that is a more holistic soil health solution. There's a lot of research going on right now, and I'll let others speak to it, but some initial studies have shown that it's really increasing soil microbial activity, water retention, root growth, these things that are kind of less dramatic than the flush of green that you would see from applying Miracle Grow to your lawn, but are actually in the long run probably more important to restoring soil health and making it possible to produce food in the next 50 years. So going back to the idea of regeneration being not just an environmental concept, but a social, environmental, economic, perhaps even racial justice concept. When we think about what a regenerative market looks like, we think of scaling through replication rather than consolidation. And so everybody's always talking about how are we going to scale? And we think it's really important that we're remembering that we have an opportunity here to do things differently than industrial agriculture on land. And that probably looks like a networked kind of growth where you have these, we're calling them reefs of 20 to 50 farms that are supported by land-based infrastructure, a hatchery, a processing hub, and a group of values-aligned entrepreneurs, institutional buyers that are making sure that that kelp has a home and that those farmers are making a living wage. We also think it's really important that we are regenerating these, justice in our economies, in our culture. And that means that we need to weave that in from the very beginning. We are at the infancy still of this industry, and we have an opportunity to protect the commons, to protect Indigenous rights, to make sure that we're being inclusive, and to collaborate over competition, because the pie is so small right now that we can't be fighting over it. We have to be expanding the pie and making there be more kelp businesses, more different uses for kelp. And we're going to get there through sharing of information and collaboration, not through competitiveness or kind of being secretive about what we're learning. And then finally, as we think of how we even got to needing bioextraction at all, we really think it's important to think of, not even, waste is not a thing. Waste, every process is going to create byproducts. And we, by taking responsibility for those byproducts, we can not just not create more problems, but actually create value for everyone. And so this graphic here is one of my favorites about kind of how that can look, even if purely from a financial perspective. So this is the Icelandic cod market in 1981 and 2011. And what you'll notice is that the total catch actually decreased by a quarter in that time. And yet the amount of money that Iceland got from that cod dramatically increased, 5x. And they did that through more utilization, better utilization, extracts, making use of the waste for fertilizer purposes. And so this really is an example of a model that we should be looking to and holding up and trying to not model. It is the model that we're trying to replicate with kelp, and I think we are off to a great start. And everyone on here on this call is an important piece of making that happen. So thank you for having us here today, and I look forward to hearing your questions.
Thanks for the great talk, Sam. Up next, we have Nora Catlin from the Cornell Cooperative Extension of Suffolk County. She is the greenhouse and floriculture specialist there, where her role is to support greenhouse growers through educational programs and research. And since 2016, also the agricultural program director. Today, she will be speaking about research that her team has been doing in association with the Long Island Sound Study Bioextraction Initiative to investigate a sugar kelp fertilizer amendment.
All right, I'm going to minimize the videos here. All right, thanks everybody. I'm very happy to be here. I'm going to start with a quick disclaimer. I am very much a land plant person, and it's been truly fascinating learning more about the kelp production in the water, but I am not a sea plant person. So please do forgive me because I'm probably going to use layman's term for seaweeds, and I might mispronounce some of your species, but I just wanted to throw that disclaimer out there. So what I'm going to be talking about is, can sugar kelp be grown for nitrogen bioextraction? Sugar kelp being grown from nitrogen bioextraction, can it be used as a fertilizer or an agricultural amendment? And we've heard a lot of allusions to its use for these purposes. So basically, can we take a sea plant and help it and use it to help grow some land plants? It's really not new for seaweeds to be used in horticulture or agriculture. There's a lot out there already being commercially used and in commercially available products. Predominantly, the ones you see on the market are the ascophyllums. The common names, there seem to be a ton of common names for this plant. I'm sure you know them better than I do, but Norwegian kelp and rockweed seem to be the two most common that I come across. So most of the products on the market that say kelp are this particular species. You do see the eclonias and the dervilias also, many times either alone, but a lot of times they're either in combination with each other or with some other product to be made into either a full complement of a fertilizer or an ag amendment. And of course, as Sam mentioned, there are definitely seaweeds being used as an animal feed supplement. I won't be talking about that today, but I know that there's some really interesting work being done with that as well. So as I mentioned, there's a lot of commercial products out there and available. There's a large variety, mainly targeted for commercial horticulture, and those are your vegetable farms, your fruit farms, your greenhouse crops. Golf and professional turf is another large market for the currently available kelp products, kelp or seaweed products, I should say. And definitely you're going to see quite a few available for the home, lawn, and garden market for your average homeowner, home gardener. There's plenty of products out there. These products are either as an extract, as a seaweed meal, or as a component of a larger product. The labels are going to say things like microbe food, growth enhancer, biostimulant, biofertilizer, or even plant growth regulators. There are some that are actual plant hormones, and they will even, in fact, have an EPA registration label. So everyone sort of already alluded to this. Sugar kelp and kelp in general is pretty low on the plant nutrition side of things. For the ascophyllums that have been out in the market and used pretty readily for years, it seems like on average, the nitrogen content is about 1%, potassium at 2%. So it'll provide some nutrition, but it really won't be your main source. Again, everyone on this call probably knows way better than me, but from what I can see, it seems that sugar kelp is more along the lines of in that 2 to 3% range. So it's not going to ever be what you're going to rely on for your fertilizer. It can supplement some of your other nutrition practices. It can help, but for the most part, it's not going to be your main source. And so I put this table up just to give you a comparison of some of the other organic fertilizers that are available. By all means, these are not the only way that growers, both organic or conventional, are going to provide the nutrition that they need for their plants. Of course, there's manures and compost and other practices, but if you wanted a bag of fertilizer to apply, these are some of the common organic fertilizer. And I just wanted to put that up to see, to show you how kelp and sugar kelp would fall in line with those. So basically, just because of their low nutrition content, kelp products are generally going to be not used, as I said, as your main fertilizer. They're going to either be used in situations where you have a high value crop where the economics are favorable to have a little bit additional fertilizer or a little bit of a boost, but mostly they're going to be used for reasons probably other than strictly plant nutrition. And again, we've already addressed this in a little bit in Sam's presentation and in some of the earlier discussion, but mostly what kelp is going to do, at least the kelps that are on the market right now, they're going to be biostimulants. So there is an official sort of pending definition of biostimulant from the USDA. They are seeking to better reel in this definition to provide a little bit better context, maybe even some labeling recommendations, possibly regulations about what you can call a biostimulant, what that means, to provide some consistency to that term. We're not there yet, but this is the proposed definition. But basically it means it's a product that's going to be added that's going to do something to improve natural processes, and it's going to improve things like nutrient availability, uptake, use efficiency, tolerance to any number of abiotic stresses, and in some cases biotic stresses as well. And anything that's going to improve growth, development, quality, yield, and even things like nutritional quality of vegetables and fruits. There's a large number of studies out there on both commercially available products as well as other seaweeds showing what types of effects that can happen. Many of these have been touched on, but anything from increased germination, improved growth, again, improved yield, fruit quality, plant quality, better root development, increased plant or nutrients within your plant tissue, be it the foliage or your fruits, vegetables, improved uptake, and also a lot of resilience or tolerance has been identified to abiotic or biotic stresses, including anything from salinity to temperatures, drought, nutrient deficiency, and in some cases, better tolerance to plant disease. The mechanisms of these activities are really they're varied and they're many. There's a lot of different bioactive compounds that have been identified in seaweeds. And these particular compounds and the activities they have are going to vary greatly depending on the specific species of seaweed you have, as well as the type of preparation and extraction. I did put up 2 review articles that do cover biostimulants and seaweeds pretty well. So I put those up there. I can share further details about that if anyone's interested. All right, so that brings us to what we did. So I found a lot of research on many other seaweeds, but pretty much no published research on the use of sugar kelp as an agricultural amendment. So we wanted to see, all right, is it possible, and what would be the effects of sugar kelp if we used it as an ag amendment? More specifically, we wanted to know, because we know that there are commercially available products that are out there and being used in the marketplace and of interest to our growers, can sugar kelp sort of fit into that market and that use as well? So we set out and we did a couple of trials. I did 2 sets of greenhouse trials, one looking at tomato seedlings, which is basically from germinating the seedling to plug, which is basically when you get that transplantable plant. And this would be the size where you would move it up into another larger size pot, thinking about greenhouse producers. And then the next one was looking at both tomato and petunia transplants. These are all pretty important crops locally, taking a transplantable plug and growing it to finish. And by finish, I mean basically when a greenhouse grower would be selling that plant. We also did a field trial. My colleagues, Sandy Menashe and Debbie Aller, did a field trial looking at field tomato from planting to harvest. I'll run through just our basic sort of procedures. We rinsed the kelp when we received it, hung it in the greenhouse to dry, which was really fun because this is not something we normally see in our greenhouses. We let it dry in the greenhouse for 3 days, after which we took it off the line, broke it into smaller pieces, and put it into a drying oven for 48 hours to completely dry the product. Then after we had the sort of hand crushed dried kelp, in 2020, we had access to a steel burr commercial grain mill, which we used. And in 2021, we didn't have as much volume of kelp. Couldn't coordinate the access of the burr mill. So we found that a basic kitchen food processor suited our needs just fine. And that was to create the kelp meal. Our process, we also use kelp extract in some of our treatments, and I'll go through those in a little bit. But our process to make the kelp extract was to take 10 grams of the kelp meal, put it into 100 milliliters of water, boil it for 30 minutes, cool it, and then filter it. There's a wide variety of extraction procedures. There's cold processing, there's hot processing, there's using various chemicals. We chose this because it was very easy and accessible to us, that we could do in-house. And also in the event that, let's say a grower would decide they would choose to want to do this, it would be accessible to a grower or even a homeowner at that point in time. So just I'll go through each trial and just the basics of which treatments we did. In the seedling trial, which was where I followed the plants from germination to transplant, I did 2 different rates of the sugar kelp extract. That's where I took the extract and diluted it to these solutions as well as controls. And I basically monitored both the percent germination rate, and different qualities of growth, root growth, and then also plant growth. The seedlings were treated weekly until harvest. The other greenhouse trial was the transplant trial, and that was growing plants basically from plug to finish. Again, treatments were applied weekly. I did the same rates of the 2 sugar kelp extract. I put in for comparison one of the commercially available products. And because we're suspecting that if sugar kelp is going to be like other seaweeds, it's going to end up having some biostimulant properties. So we looked at the effects of sugar kelp extract at low fertilizer rates to see what effects that might have. Additionally, here at CCE Suffolk, and of course on Long Island, we're all working towards ways for growers and everyone to reduce their nitrogen inputs and find more efficient fertilizer practices. So that was, of course, our other interest. And again, I followed through monitoring the plant growth and collecting data on plant growth, root health, and then I did actually a drought trial at the end. So I'll go through, and I apologize, I have some boring tables for you guys. I'm going to go through some of the results. In 2020, I had a really nice clear cut, hey, I did see a growth increase with the sugar kelp extract in the greenhouse seedlings. Now, these differences are so minor, but they were significant. I had a really nice set of uniform seedlings and a lot of reps. So we were able to determine those differences. The differences, unfortunately, in 2021, I had a lot of variability, and I did not see any difference in 2021 in the growth of the seedlings. In both years, I really didn't see any significant effects on either percent germination or germination rate. That's, the time it takes for a plant to go from seed to germination. On the transplant trials, far less clear. Can you guys see my mouse? Just to orient you a little bit, the darker green are the plants that were fertilized with the standard rate of fertilizer. The lighter green is the half dose of fertilizer. I'm going to start with the 2020 in the petunia, because this was the first year and I got this data, and I was really excited because it was fairly tidy and it was pretty interesting. So what the big takeaway here was that, one, we did see a growth increase from our untreated control with the sugar kelp. And then more importantly, I thought what was really interesting is that we saw basically no difference in size with the plants grown at the low fertilizer rate. So that was great for 2020 and petunia. The story in the 2020 tomato wasn't particularly clear. You're seeing differences, but the differences are really only lining up with the different fertilizer rate. 2021, same for tomato, it was the same as 20. The differences are strictly just falling out with the fertilizer rate. And petunia, unfortunately, it didn't repeat. The results in 2021 didn't repeat the results we saw in 2020. So, you know, I'd love to be able to have another stab at this to see if I can confirm, at least with certain plants, if we could grow them at a lower fertilizer rate with sugar kelp extract added to get them to be equal to a plant that would be grown with a full rate of fertilizer. You know, and maybe the answer is, maybe it's not a 50% reduction in fertilizer. You know, maybe I go down 25. But I think showing that we might be able to have a use for sugar kelp and reducing fertilizer would be a really nice addition. This is from 2021, just an image of the plants. Again,
Nora, we have to move on. I'm sorry.
Oh my God, really?
Yeah.
Okay.
One last slide and then.
Yeah. No, I'll go through the will. I'm happy to
Sorry.
share any of this. Basically, no significant after doing some trials. There might be something there. So I thought that was interesting, but I can't hang my hat on it. The field trial, we're not seeing differences. But in anything, in the reduced rate or the commercial products. So I will go to just the final thoughts. It's really hard with the variability on the weather, field, and other conditions. So it's really hard to quantify differences. We might see some differences, but nothing we're quite ready to hang our hat on. So do we know the specific effects? No. There's possibilities there. I think there's more work we can do to identify them. But is there a market? And given that we know that the other products are being used, we're even having a hard time determining the effects of the commercially available products, I'm going to say yes. All right, so I'll leave it there. I apologize. Wow. Okay. Follow up. Anybody feel free to reach out to me. I'll give you more information.
Thank you so much, Nora. And just
certainly.
No, just as a reminder, we do have plenty of time left over for questions and answers following the session. So Nora, let's convene.
Absolutely.
Thank you for the presentation. All right, our next speaker is Kris Mielenhausen from Rocking the Boat. This organization is a youth development nonprofit based out of the South Bronx in New York City. There, he is the director of environmental programs and oversees the environmental science apprenticeship program. Today, he will be talking more about his work there, including a new Grassolaria bioextraction seaweed farm project.
Hey everyone, can you hear me okay?
Yes.
Great. Thanks, Jordan, for that intro. Let me just share my screen. Hi, everybody. My name is Kris. I'm very happy to be here today. Thanks again, Jordan, for that intro. Today, I'm going to be presenting about my organization's new bioextraction project. The title of the project is Engaging Local Youth Through Seaweed Farming to Improve Water Quality in the Long Island Sound. We are funded by National Fish and Wildlife Foundation, Long Island Sound Futures Fund, and additional support was provided through the New York State DEC Community Impact Grant Program. A little bit about our organization. Rocking the Boat is a youth development organization. We're located in the South Bronx in New York City. We serve teenage participants aged 14 through 19 through the implementation of 3 different hands-on experiential education programs. We have three tracks of study. We have sailing, wooden boat building, and then the environmental science and restoration program, which is the program that I run. Our young people generally enter the program either in 9th or 10th grade, where they learn kind of the ropes of their focus area. You know, they learn to swim, get comfortable working along the coast, get comfortable rowing boats and working aboard boats, and also gain foundational knowledge and skills in their chosen area of study. When the young people are juniors, usually juniors, sometimes seniors in high school, and they've mastered a certain set of technical skills, they have the ability to interview and then become paid apprentices in their focus areas. Our apprenticeship program is called the Job Skills Program, and for many of the young people here, it's their first real world kind of job. Just to literally put it on a map here, I think that you guys can see my cursor. This is rocking the boat here. Right here is the Bronx River estuary. This peninsula here is the Hunts Point section of the Bronx. It's where all the food markets and the fish market are for all of New York City. And just to pan out a little bit more, here you can see where rocking the boat is, and right here, right about here is where the grow up portion of the seaweed farm is going to be, at the confluence of the East River and the Bronx River. So currently the Environmental Science and Restoration Apprenticeship Program has five main projects that we're working on. The first is a weekly multi-parameter water quality testing project. We test for DO, nitrates, pH, salinity, turbidity, and we also do weekly pathogen testing for Enterococcus. This slide on the bottom is part of, it's one of the quanti trays. We use the IDEX quanti tray system to analyze Enterococcus. And the top picture is one of my apprentices doing water quality. We also have a microplastics project. This project, it's a pilot study for the Bronx River. It's been going on for about 3 years. This is, we work closely in this effort with another organization called the Bronx River Alliance. The picture on the left, these are apprentices on the Bronx River collecting microplastic samples, and they're right underneath the Bruckner Bridge overpass. This photo to the right is microplastics analyzation. We also do oyster reef monitoring, fieldwork, and data collection in partnership with Billion Oyster Project at their Soundview Reef. It's located just outside of the mouth of the Bronx River. If you look back here, these buildings along the coast here, that is essentially just to the left of those buildings is where the grow up portion of the seaweed farm will be. To the right, the photo is just spat on shell from the oyster reef there. And we basically collect data for Billion Oyster Project there, measuring the heights of live oysters and dead oysters, observing for signs of predation or actual predators within the gear, and other companion animals also in the sampling gear. We also have a salt marsh restoration project where we are growing Spartina alterniflora from seed and planting that at 4 different sites. The photo on the left here are some of our young people installing coir logs at the Hunts Point Riverside Park location. And on the right, we have some of this year's seedling starts. So finally, our new bioextraction seaweed farm project. This photo here is a picture of our Gracilaria. It's Gracilaria tikbahe. just before it was shipped to us from a place in Maine called Bigelow Laboratory for Ocean Sciences. The strain that we're using for this project is actually Dr. Charlie Yarish's. It's from his Yukon collection that is just being housed now up at in Bigelow, Maine. The project's objectives are threefold. We want to harvest the ecosystem services provided by seaweed for the purpose of reducing nitrogen in the water column. 2, to develop and utilize nutrient-rich soil amendments in local community gardens. Along the lines of both what Sam and Nora were kind of pointing to, we're not calling it fertilizer for all of the reasons that they mentioned. We're calling it soil amendments for the purpose of this project. And number 3, you know, we kind of our bread and butter, we really want to educate the local youth here, and then a subset of the larger community about nutrient pollution, combined sewer overflow, and the benefits of bioextraction. This is a photo of our small nursery setup that we have here in the lab. This is a picture of the Gracilaria shortly after it arrived on the left, and to the right, this is just a picture of the kind of large vessel that we're going to be getting in the lab here to scale the seaweed, to basically bulk it up enough so we have enough material to actually put it out into the farm system out in the water. So on the left is a cross section of our proposed seaweed lines. We are at just about 30 feet of water at low water at the location. We're going to have 220-foot long lines, and the seaweed is going to be about 3 feet or 1 meter down in the water column. It will be suspended by buoys every 20 feet, and we're going to hang a brick or a cinder block. We're pretty sure it's going to be a cinder block from one of the, basically countering each of the smaller 1 foot diameter buoys to kind of like hold things steady there. And the picture on the right is actually, this is an apprentice from 10 years ago with holding up Gracilaria at the almost exact location where we are doing the farm this time. This was a project, it was in 2012 with University of Connecticut, and this particular project, I was not here for it, but it was in unison with growing mussels from the raft that you see behind this young person. For our project, the harvest schedule we're thinking is going to be every other week during the summer and fall. We're going to be going out there at least weekly to monitor and make sure everything is okay, and then hopefully again harvesting every other week. And we're going to be sending out the Gracilaria tissue to be tested for carbon and nitrogen from an outsourced lab. So the next steps in our project are going to be producing this soil amendment and then sharing the soil amendments with community garden partners for community engagement and education. In terms of making the actual soil amendments, we're going to be trying 2 different things. We're going to be soaking it in fresh water to be making a liquid tincture. And then we're also going to be experimenting with drying some of it in a greenhouse and then grinding it down almost to like a coffee grind type consistency. So that's going to be the second kind of soil amendment. So these are some photos of a community garden here in the South Bronx called the Garden of Eden. They're one of our gardening partners, and if you look around at if you look at these pictures, the first photo here, I think this first little box here, that looks like corn to me, and these folks over here on the right look like they're growing some cucumbers. I want to stress that for our purposes, we're growing this seaweed in the Bronx River. We're not going to be using the soil amendments on anything at this point that's edible. The Garden of Eden has a pretty sizable pollinator garden that goes all around the front of their garden on the street side, and that's where we're going to be using these soil amendments. But the main reason why we're going to be sharing, what are the work that we're doing with these community gardens is for education, right? So the environmental apprentices are going to be spearheading a series of educational events at the garden, talking about the benefits of bioextraction and the issues with nutrient pollution, especially from combined sewer overflow in and around urban areas and specifically in New York City. We're also in partnership with Wave Hill Garden and Cultural Center. This is in the Bronx, but in the Riverdale section of the Bronx. So it's northern Bronx on the Hudson River side. The apprentices will also be presenting the soil amendments there. And at this particular garden, they're going to be put to use on a couple of fields that they have in the back portion of their property that they're transitioning to back to all native plants and grasses. And then for the final phase of the project, we're going to be taking the leftover biomass that we have from that we have left over after we make the liquid soil amendments, and we're going to be taking that from our compost pile and bringing it to Department of Sanitation. Has a very large composting site on Staten Island, and we are going to take the material to add to that composting site, and the young people are going to kind of have what we call a teach back with the Department of Sanitation composting staff, where they are going to learn about composting from those individuals, and then again give their presentations about the work that they have done, to deal with nutrient pollution through bioextraction, through growing seaweed, and they're also going to talk about the other restoration efforts that they are a part of here on the Bronx River. So to kind of wrap it up, our project goals are hands-on science and technical job skills training for the participants here, and demonstration work, right? Like showing the potential for an ecosystem service industry that addresses nutrient pollution in our urban waters, exhibiting the potential of creating a closed loop cycle by supplementing fertilizer with bioextracted soil amendments, and then environmental justice advocacy and empowerment through citizen science and community education. That's all for me. Thank you, everyone, for listening, and special thanks to our project funders and our scientific advisors and partners listed here on this page. I look forward to the questions and the overall conversation.
Thanks so much, Kris. So now we'll have our question and answer session. So I can like to invite Kris, Sam, and Nora back on. Please turn your cameras on and your microphones. We'll have about 20 minutes or so, 15, 20 minutes to just dive a little bit more into some of the talks that we had, that we just had. Let me go through some of the questions I had seen in the chat, and I think we'll start there. And also any attendees, if you have any further questions or follow-up points, drop them in the chat and we'll be more than happy to keep the discussion going. Okay, Sam, I think the first question would be directed towards you. And we had a question come in asking, does Greenwave only work within Connecticut? And if so, or if not, are there any plans to expand?
Yeah, absolutely. So Greenwave is we consider ourselves to be a bi-coastal organization. So we work throughout New England. We also do a lot of work in Alaska, and we actually have one of the first commercial ocean farms in the state of Connecticut. So we are active in all those areas, and we also have kind of international partnerships, although we're not doing any of that hands-on work ourselves over there. We are supporting partners in doing that. Yeah, so that's where we are.
A follow-up question for you, Sam, that just came in is, how is Greenwave similar and or different to Maine's aquaculture business incubator?
Well, I would say one difference is that we are not, as of right now, we do not kind of bring businesses into the fold and kind of actively, we don't provide funding for businesses. We don't, we're not, we don't exist to, how would I describe it? Like we are more facilitators and kind of a networking organization than a cohort-based one, although we have discussed doing some cohorts, particularly for areas where we see bottlenecks, like things like processors. But the farmer training programs in particular are services that are totally free, that we go out and offer. Any of that regenerative ocean farming hub is completely free. And so I think it's those two areas of training and support and innovation are really our focus versus funding or supporting individual businesses as they go on their trajectory from startup to growth.
Great, thanks, Sam.
Yeah.
All right, bear with me as I look through the questions here. Nora, I believe this question's for you. Would you encourage sugar kelp as an agricultural amendment in the future? And do you think more research is needed for these I want to use the right word, biostimulant products? Yeah,
I don't, I'm not at the point where I wouldn't discourage it for sure, but I don't know that I have, if I make a recommendation to a grower, like I'd like to have something specific to say, like I've seen research that's been repeated that's shown that it's potential to help you with drought stress, that's going to help you improve. So I'd like to see a little bit more research to better determine what crops, what applications, what rates are most effective before I would go out and recommend it to growers.
Okay, great, thank you. Let me look through our questions yet again. Just a question I had of my own for Kris. Most of your business involves a lot of partnerships and reaching out. Would you be able to sort of say, what are your strategies for reaching out? Are you posting at community colleges, different universities, high schools? I know you mentioned a few high school students, but just kind of give us a sense of how you're letting people know that you're there and making people aware of that.
Sure. So do you mean how do we recruit the participants, or how do we network around scientific partners and the projects that we do?
I'm more interested in the recruiting. And yeah, how do you get those interested parties from not necessarily knowing this something like this exists to then coming and signing on to the apprenticeship program?
Yeah, that's a great question. So we have public programs here also that are more The student program that I described is generally high school age kids that are in 9th and 10th grade, and then once they get through that portion of it, they can apply to be apprentices, which are usually their junior and senior years. But before that, and that meets in the spring and fall after school, and then in the summer we have like an intensive field kind of season that they meet. They come 3 or 4 days a week for 7 weeks straight for full days. But before that, we have public programs that run sort of more like kind of like field trips, where like an entire science class might come, and those young people are in middle school for the most part. So they kind of get a taste, and they you know, get on a boat and get out on the Bronx River, and they're like, wow, this is really cool. How do I get involved? So that's how we do it. And we also have partnerships with a lot of the local high schools in the South Bronx.
That's great to hear. I asked because I had received a few emails ahead of time of the symposium asking, you know, how do I get involved? You know, even as young as a middle school student, saying, I'm excited to sort of skip school and come in and see the symposium. So I just want to make sure we touched upon that.
Yeah.
So thank you for that.
Send them our way.
Yeah. Oh, absolutely. I think that this is a great post for the symposium, is helping kind of get that networking and making those connections. Nora, I want to direct another question towards you about the kelp amendments. Do we think that the kelp would be better for non-food plants, say flowers, as opposed to food crops, tomatoes, cucumbers, and going on?
Yeah, I think it would depend. I think there's a lot of interest from, in particular, the high value organic market. So if it's proven to be a safe amendment, I think there will be a lot of interest and use and need for it in that area, because organic fertilizers can be challenging, you know, certified organic fertilizers can be challenging to come by. But if there are contaminants of concern, then by all means, I think the large ornamentals market would be, you know, a good option, you know, once we can better figure out, you know, if there are meaningful and measurable effects with the products.
Okay, great, thank you. Bear with me one moment while I look through the chats again. Sam, I had a question come in for you, asking if Greenwave works with any other species besides sugar kelp, and if not, do you see any potential for growth into those markets?
Yeah, so we do support farmers on incorporating shellfish into their operations. As far as seaweed species, we are partnered with Woods Hole on some of the kind of learning more about the variants of sugar kelp. So learning more about skinny kelp up in Maine, and then the different phenological, or is that the right word? Yeah, phenotypes of sugar kelp. As far as other species goes, I can't actually speak to what the hatchery is working on right now, just because I don't work in that area. On the market innovation side, we are definitely paying attention. I'm sure some of you saw that Springtide Seaweed got a grant to look at nori and dulse cultivation in the Northeast, which we think would be great. There's a lot of demand for that. But we're kind of limited by the ability, you know, by the research being there to support consistent production of seed, so that it can be planted consistently, so that we can have consistent harvest levels. And we're seeing this as a bottleneck on the West Coast when it comes to bull kelp, where there has been some research done. Like we know how to seed bull kelp, but we haven't actually been able to figure out the right structures so that it grows consistently. And that's a really big issue for connecting the farms to the market, because if you can't, if it's just like wildly unpredictable harvest yields, that's very, very challenging to build up a customer base for. So I would say we're kind of waiting to see how the different species, the research into cultivating different species evolves.
That's great, thank you. I like hearing the connections from, taking what's primary research and then sort of identifying those problematic areas where, we're worried about the end use of the product. So thank you for that. Let's see, I had a couple questions come in for Nora. Is the Cornell Cooperative Extension studying uptake of heavy metals, PCBs, as part of the fertilizer amendment study?
Not our side of it, but I believe that there were tests being done on the marine side of things to get a sense about what is going on in the kelp tissue specifically. I was dealing only with once it came out of the water and on land. So I don't know if somebody else on the line might be able to answer that, but not my side of things.
I can just jump in for a second. On the kelp growing side in the water, we were doing tests for that kind of things. But as far as the fertilizer, our focus was more on, is it helping plant growth? So for this study in particular, we weren't looking at things like, oh, are the tomatoes uptaking any contaminants? But that's definitely something that we are looking into in the future. We're actually going to be working on a project that's already started with SUNY SOMAS about that this year. So
oh, I might have misunderstood the question. I thought you were asking about the kelp tissue, not the vegetable tissue. So no, we didn't follow through and look at potential contaminants. We did do basic nutrition analysis of the tomato fruit after the fact, but we didn't do anything else.
Okay, great. I think we'll have one. As I swear, the moment I say we're gonna have one last question, then I always get more. So it's a good problem to have. Anyway, this next question would be for Sam again. Sam, what do you think are the most promising market or markets for sugar kelp moving forward?
I'm gonna do a non-answer, which is all of them. But I really do mean it. I think that we need to take a portfolio approach. So let me kind of reframe it. Is I think what the question that I ask myself, and that we're trying to think through how to support at Greenwave, is what is the current scale of production happening in this country, and what industries match to that nicely. So, one of the issues with biofuels, which people have been excited about for a while, is like, you would need so much kelp in order to make that possible. And we just aren't there yet. I mean, Atlantic Sea Farms is the largest purchaser of sugar kelp in the country, and they're purchasing about 1 million pounds this year. And so talking about something that requires 5 million pounds per year is just not reasonable for right now. So we're really looking at what are the markets that are right sized for where the industry is today, which is mostly food markets. Just the volume lines up. And then what are the industries that are up and coming that we can incubate with pilot projects and support them, getting them a kelp that is intended to help them in early stage product development, and encouraging them to start communicating with us and with other aggregators and processors, so that people can start to plan for that ramp up. Because otherwise you end up in this kind of chicken and egg situation where the farmers don't want to plant kelp because they don't have a buyer, and the buyers keep saying, well, there isn't enough kelp for me. So we have to kind of meet halfway and start planning long term. And I think that starts with these pilots and very small scale production, and then a plan for ramping up over time in a way that works for both, for the farmer, the buyer, and then whatever processors happen to be in between.
Okay, great. I think in the interest of time, I will take one last question for the panel. just as a reminder, we will have follow-up. You know, you can email myself or Kristin, and we'll get those questions answered for you. Just the last question, I'd like to hear everybody's opinion on this. What are the recommendations for aquaculture with kelp farming that helps avoid those pitfalls we see in modern land-based agriculture? And the example given would be monocrops. And it's okay if we can't. That's such a large question.
You know, I was like, I can comment, but it's really out of my wheelhouse.
Yeah.
Go ahead, Nora. You go first.
Well, you know, like, where do you start there? I mean,
Sure.
when you talk monoculture, you just don't want to have all of the same things. So again, I think they're way out of my wheelhouse. So if you can vary the genetics, you don't want to use the same plant, the same cultivar. You know, you go back to when you talk about the Irish potato famine, it's because there was very limited genetic diversity of the crop. So I think first and foremost, just making sure that you can have some sort of genetic diversity so that if you have something, whether it's temperature, disease, it's not going to kill everything. It'll just maybe kill some of them. So you won't have a mass epidemic or pandemic, if you will. That would be my comment coming from the land side of things.
I think the land side is very valid here. Thank
You
you.
can learn from us, right?
Yeah. All right.
Yeah, and I would come back to that idea of scaling through replication. I think that a lot of the problems that we see on land have to do with consolidation and a one-size-fits-all approach, and trying to force ecosystems that are not designed, ecosystems or crops that are not evolved to do certain things to do them, and that has kind of disastrous effects. And so I think the idea that you have a model, and then when you replicate it in different environments, it might look a little different, and it has to be adapted for that local environment and people and species in order for it to work, and that's fine, and perhaps even more resilient and more valuable long term.
Okay, I think for such a large question, we did fairly well handling that. Thank you all for your presentations and for your attentive and your answers. I'm gonna invite Kristin just to back onto camera to give a brief wrap up for the day, and then we'll see everyone tomorrow. So Kristin.
Thanks, Jordan. I want to thank everyone for the great questions, and of course, thank you again to all of our speakers. That marks the end of day 1 of the symposium. Join us again tomorrow at 1 p.m. Eastern time to hear more presentations. Coming up, we have presentations from the New York State Department of Environmental Conservation, New York Sea Grant, Connecticut Sea Grant, Keene State College, Farmingdale State College, and the University of Maine Center for Cooperative Aquaculture Research, where we'll be focusing on seaweed regulations, state perspectives and economics, and also business development. We'll also have an opportunity for extended discussion in our last section, as I mentioned earlier, that's entitled Identifying Next Steps, which will be an open forum for all participants to revisit topics presented at the symposium, comment on what important next steps might be to advance the bioextraction industry in Long Island Sound, or bring up questions that still need to be answered, or things that you feel that we may have missed. So thanks again to everyone who joined us today, and I hope you have a wonderful evening, and we'll see you again tomorrow.